So there's early start, early finish, late start, and late finish. And then they also use just the duration. All right, so LF is the late finish. EF is the early finish. LS is the late start. And ES is the early start. And I want to also include one more thing. We just compute those within someone else. Okay, so these are all going to connect to an N block. If they just seem to be hanging, then you'd connect them to the N block. So the purpose of this exercise is to figure out all these early start, early finish, late start, and late finish times, and then to identify what the critical paths in the network are. So again, you never do this stuff by hand, but here's how it goes. Right, so by convention, every node connected to the start block starts off with an early start of 0. Okay? And then it's going to have an early finish that is, in the case of A, all right, let me just add these times in here. So it's 4, 10, 13, 12, 7, 2, 6. So maybe I should do this. I'm going to put all the early start, early finish in blue just to make it a little bit more legible for you. So because these are connected to the start block, the early start for A and B are both 0. If I do start A at time 0, then it can get done at the earliest at time 4, right? Because it takes 4 time units.
So you're just adding it?
I'm just adding it. And for B it would be 10. When is the earliest C could start?
12?
Or 4. As soon as you're done with A, you can do C. You must respect the precedence, but once A is taken care of, then you can get started with C. There's going to be no necessity to do C right away. You might choose to, but we're just trying to get this. If you did choose to push it as hard as you possibly can, then you would start C at the earliest of time 4 and get down at the earliest of time 17. That would allow you to get E started at time 17 and done at time 24 at the earliest. This example is not very conducive for a great example, but gets us started. So for D, it will be 10 and 22, because B must precede D. D gets done at time 10, so I can start D at time 10, and it takes 12 time units, so it can get done at time 22. And so F could start at 22, get done at 24. G could start at 22 and get done at 28. All right. So I know what the earliest completion times are for E, F, and G. How long is my project going to be? At the shortest. (28 time units). 28 weeks or 28 days. How do I know that? It's the longest of all of the early finish times of nodes connected to the N block. All right, so what I'm doing these two guys on a forward pass of the network. And I'm going to do these two on a reverse pass through the network. Okay, so by convention, I'm going to take as the late finish on all blocks connected to the end block, the project duration. So that's 28. Okay, that is by convention. And then I'm just going to deduct and I'm going to go through. So if I did finish at the latest at 28, it means I could do a late start at the latest by 21. And this one here would be a late start of 26. And this one a late start of 22. All right, now there's a little novelty. It's the first time we've encountered this. My question is, when must I finish this one by at the latest, if at the latest this one's going to start at 22 and this one at 26? When must I have this one done by?
26.
22. And I'm going to put it in red.
Wait, why is it 22?
This one wants to start at 22.
Oh, that's when you can start with.
Yeah, the late start of this one is 22, so
I
you
see.
must have gotten done with this one by then. So on the way back, it's going to be the minimum. If there is a run-in. On the way forward, we didn't have this, but you're going to have a max. So I will do another couple of examples for you to show you how these calculations work. This is our first example. But this is the sort of resolution that we want the software to square away for us. So if it finishes at the latest 22, I can get started at the latest at time 10. This one can start at the latest at time 10, finish at the latest at time 10, start at the latest at time 0. At the top, this one is 21 minus 13 is 8, and 4. Okay. So, what do I know? I know the early start, early finish, late start, and late finish of all of these activities. These are useful numbers to give to contractors. Some of them are 4 days apart. You tell the contractor, you might have shot it starting on day 17. The latest we're going to get you out here is on day 21. And the finish times would be pretty much up to the contractor. That you need to give the contractor a sense of when they need to get out here. Now there's another thing that we need to calculate. I'm going to calculate the slack for each activity. I'm just going to put it on here. It's the late start minus the early start. You just look to see what the difference is between late start and early start. So for this story here, it's 4, 0, 4, 0, E is 4, F is 4, and G is 0. So it gives you a sense of how critical an activity is. If it has a slack of 0, it's important. It needs to get done, like clockwork. Now, the thing that I'm trying to identify in this next phase is the critical path. The critical path has all 0 slacks. So my critical path is B, D, and G. It causes the project to have a duration of 28 if you execute it perfectly. Notice that the other paths, I can let A or C or E slip, total up to 4 days across the 3 activities, without impacting the overall duration of the project. If I did do them like clockwork, they'd get done in, ACE would get done in 24 time units. It's 4, 7, 4, 13, and 7, right? Those are the time commitments for A, C, and E. But if I did want to let them drag a little bit, take a 4-day vacation, then get started, I'd still be okay without it impacting the overall duration of the project. The overall duration of the project, again, is key because you want to get done. You might have taken like site insurance policy that end on a certain day. You don't want to come back and have to sort of reinsure for a week or something. It gets expensive. Your rentals for the site office, the site truck, some of the cranes and all this good stuff would have been set up for, for the duration of the project. So you don't want to have to renegotiate that stuff. Also, you may be paying that penalty if you did agree to some contractual penalty for a time overrun. So that's why we're critically concerned with getting the project, and it's the critical path or paths that need to be managed very closely. This is the bottleneck path you want, and the other paths, you have a little bit of slippage, but nothing, I mean, a slippage of 4 is nothing in the real world. Something that would be a meaningful slippage would be maybe like 10 weeks of slippage. 4 days is as critical as everything else, because 4 days, anything can happen.
Wait, why'd you pick G? I thought you picked F because of the straightforward.
No, there's a difference here of 4.
Oh, okay, so
This is the one.
that's where you're looking, okay.
Yeah, the issue for the critical path is that all the activities on the critical path have 0 slacks. Okay, go and look at the table.
I see what you're saying, all right.
B, D, and G are 0 slacks. Questions, folks? This is on the table. Yeah, this one, not the next one. The next one is like 100 times more challenging than this. Folks get this one down after a couple of examples. Now it looks a little sketchy right now because you did one example, but sketchy as it is a sketch. Any questions about this one?
So, what information would you give us for the test?
Just what you see on the table.
The table?
Absolutely, less the slack column. Yeah. So I'll just give you the predecessor and time information, tell me, okay, figure out all the LS, ES, EF, and the LF data, tell me what the slacks are, tell me what the project duration is, and tell me what the critical path is.
How would we figure out how to make that?
So how did you create the path?
You start with.
All right, so these guys have no predecessors, so that's why they're connected to the start. Okay, so you have a start node. And then C is connected to A,
Oh.
and D is connected to B, so it's only connected to B. And then E is only connected to C, and so forth. And then when I had a bunch of stuff hanging at the end, you just put a bunch of arrows toward the end node. So anything that's left, yeah.
Can you do the one that's in the notes? Because I'm
Sure.
having a hard time trying to connect the
Okay, which notes?
notes that you posted online.
The
You
PowerPoint?
have an example.
PowerPoint?
No, the actual, your notes that you,
The exam review?
not the example.
No?
you,
Which
Chapter
one?
17.
Okay, just tell me exactly where you are.
It's on page 8.